Okay, general angles on the coordinate plane. So basically, once we've been talking about trigonometry, about right angle triangles, and how to use right angle triangles all the time. The only thing that we did a little bit differently was when we did bearings and our angles sort of started getting a bit bigger than 90 degrees. Well, when we're talking about trig, we can actually have a trigonometric ratio of any angle. It doesn't just have to be between 0 and 90 degrees. But what you might notice, if I'm using any angle, then obviously triangles aren't the only thing that trig can be used for. Okay, so I'm going to start off by drawing up a coordinate plane like this. Okay, so here's my Cartesian plane, x and y. Okay, and I'm going to make it 1 long. Now, when we measure angles in the coordinate plane, we start with a ray pointing along the x-axis with vertex at the origin. So basically what we're saying is we've got a arrow, okay, basically starting at the origin, okay, and pointing in that direction. Okay, then we rotate the ray in an anti-clockwise direction to give angles of theta. Okay, so a ray from here to here, and what we're basically saying is we rotate it anti-clockwise to get an angle of theta. Okay, so our angle is measured from that pointing to the x-axis around anti-clockwise, and it can be bigger. So, we could have one pointing down this way, which would be all of that, or we could even have one that's smaller, that's here, that's only there. Okay, so what I'm saying is that when we draw, or when we measure our angle, we start with this x and we go anti-clockwise around. So as I said in the bearings video, it's frustrating that bearings are done clockwise because pretty much everything else is done anti-clockwise. So all angles between 0 degrees and 359 degrees can be described between 0 and 1 rotations in the anti-clockwise direction of a ray. Okay, so let's say we had, for example, an angle of 400 degrees. Okay, so let's say we had, 400 degrees. How do I represent that? So to represent 400 degrees, okay, well, if one rotation is equal to 360 degrees, then this is just 40 degrees more than 360 degrees. So if we draw up a new coordinate plane for this one, okay, so 400 degrees, so basically we do a full loop around, plus we do 40 degrees more. Okay, and so what we say is then 400 degrees is the same. So 400 degrees is equivalent to 40 degrees on a Cartesian plane. Okay, so which can be pretty handy. So the quick way to do that is just do your 400 minus your 360 degrees, and that will give you your 40 degrees there. Now, let's say we decided instead of doing one like that, we decided to say, well, what happens if we have one that's negative 10 degrees? Okay, so what about negative 10 degrees? Okay, so when we increase our ray, or the angle between the x and the ray, okay, we move it in anti-clockwise direction. When we introduce negatives, well, instead of going anti-clockwise, we in fact just go clockwise that amount of degrees, okay? And so that's that ray there. Okay, so it's 10 degrees less than 0 degrees, okay? So it's 10 degrees in the opposite direction. Now to work this one out, all you basically need to do is you need to add 360 on to this angle. So 360 degrees plus negative 10 degrees. And this is equivalent to 350. So 360 degrees is equivalent, or has the equivalent ray to, oh, sorry, not 360, negative 10 degrees is the equivalent to 350 degrees when between 0 degrees and 360 degrees, okay? So we can turn all of these rays back into, between 0 and 360 by just applying some common sense, okay? If it's more than 360 degrees, how much more is it? How many more rotations do I need to do? So all these angles are about rotating a ray around in a circle until you get to a certain point, okay? So that's it for this video. I'll talk to you in the next one.